Constrained optimization. What exactly is constrained optimization? Let's look at this graph first of all. Here I've drawn this fx curve. Okay. Now this is an example of unconstrained optimization. You are trying to optimize it over the entire range. Okay. Sorry, over the entire domain, and what you get is that this is the maximum value of f. Okay, as dy by dx is equal to 0 at this point. Fine. Now the point is that in case if I ask you to look at the restricted domain, as I've copied the same function here, but I've restricted the domain by these two pink lines here, and I'm asking you to find out what is the maximum value of f here. Now the maximum value of f in this case is coming out to be at this point, say at x star c. At this point the value of f is fx star c. So the motivation is that the solution to the unconstrained and the constrained problem may not be the same. Okay, because in the unconstrained problem you are trying to optimize it over the entire domain of the function. Okay, but in the constrained problem are constrained by a restricted domain. Okay, you're trying to see that what is the optimal value of the function over that restricted domain. I'll give you one mathematical example also in order to give you a little more intuitive explanation for this. Now we have put a constraint over this unconstrained problem. So this is the constraint that you have to optimize this f subject to this constraint. Okay, so this constraint could be written as x is equal to minus y minus 1 minus y. So in case if you substitute this x back into the objective function, so what will you have is 2 into minus y minus 1 square plus y square minus 2 into minus y minus 1 y plus 3. As you could see, this entire function has now become the function of only y. So this is an unconstrained problem now only in terms of y. So you can write this as 2 into y square plus 1 minus 2. In this recording, we'll talk about how to use Lagrangean method for optimizing any objective function over set of certain constraints. Now, I'll give an example first, and then I'll give the general view of the problem. So, supposedly, in case if you have the function f of xy is equal to 2x square plus y square minus 2xy plus 6. Okay, and the constraint is gxy, which is equal to x plus y is equal to 1. So you can form Lagrange where the method is going to find out the optimal values of x, y and lambda such that you try to optimize 2x square plus y square minus 2xy plus 6. This is your objective function subject to the constraint. This is the constraint and this is the Lagrange multiplier, and you write the multiplier as constant minus variables 1 minus x minus y. Why do you write like this and why not x plus y minus 1? We'll see it later. And then how many variables are there? There are 2 variables x and y. So you will find out, so you will write that there are 2 variables x and y, I is equal to 1, 2, and there are how many constraints? There is one constraint, j is equal to 1. So you will find out